All right, let's look at the homework 3.1, problem number 9. All right, so let's find the critical number of this given function here. All right, first I'm going to look for the domain too. Here, since you have a fraction, we have to make sure that the denominator is non-zero. So we know that, so we want this guy. So x squared minus 64. We want this to be non-zero, right? Since this is a difference in squared, so you have you can factor it out as x plus 8 and x minus 8, and we don't want that equal to 0. So we know that x cannot be equal to plus or minus 8, right? So we have to eliminate that. All right, and a positive 8 and negative 8 cannot be critical numbers. All right, so we need to find the derivative to find the critical number. All right, so this is going to be equal to. All right, so we're going to use a quotient rule. All right, so first square the denominator. So you have x squared minus 64 squared. And take the derivative of the top. So I'm just doing the quotient rule and times the denominator. So quantity x squared minus 64 minus top, which is x squared, multiplied by derivative of the denominator, which is 2x, right? So you have 2x. All right, we need to simplify a little bit. So since we have 2x in common on top, so you have 2x and 2x, I'm going to pull that out. So you have a 2x. And the leftover terms are x squared minus 64. So you have x squared minus 64. And also from the second term, we have negative x squared, so minus x squared. Right? Then the denominator is still looking good. So you have a quantity x squared minus 64 squared. Then we can luckily cancel x squared minus x squared. And clean it up, you see that, let's see, I'm going to combine negative 64 and 2x. So it's going to be negative 128x over quantity x squared minus 64 squared, right? So to find a critical number, we set that equal to 0, right? But we can just simply make sure that the numerator equals 0. So you have negative 128 x equals 0, and which gives us, you can divide through by negative 128. So you have x equals 0. All right, so x equals 0 is the critical number. All right, so let's put it in. All right, x equals 0, and let's check the answer. All right, it came back and looks like we got the critical number correctly. All right, so let's look at the increasing, decreasing behavior of this function. All right, so we're going to just do a number line. So draw a number line. And the critical number is 0. All right, so we put that. And also, since we cannot include the negative 8 or positive 8, so we're going to put the negative 8 here. And also positive 8 there. Then we're going to look at the sign of the first derivative. So you have f prime. All right, so we can try basically any number you want. So let's try something like anything smaller than negative 8. So I'm going to try x equals negative 9. All right, so if you look at the f prime, so this is the expression. All right, you can see that denominator is always non-negative because it's squared. So we just have to worry about the numerator. So if you plug in negative 9 for x, so negative 128 times negative 9 is going to be obviously positive. So it's going to give you a positive first derivative, right? And if you try anything between -8 and 0, I'll try x equals -1. And you can see same thing, -128 times -1 is going to be positive. So we have a positive derivative there. And then we can try x equals, say, 1 between 0 and 8. And now this time, so -128 times 1 is negative, so you're going to have a negative derivative. Right? Then we can try anything bigger than a, so I'll try x equals 9, and -128 times a positive 9 is going to be negative, so we have a negative. Right? So if you're looking at the behavior of the original function f, it's going to be increasing here and also increasing here, and after that it's decreasing here and decreasing there. All right, so anything before 0, not including -8, it's increasing, and after that it's decreasing. So let's type it in. All right, so increasing from negative infinity. All right, so let's see, where's the infinity symbol, maybe? Yeah, infinity up to -8, and using, let's see, then -8 to 0. All right, and do we need to use interval notation? Does not exist. All right, so I'm going to probably use union. So we have set, then union, and decreasing after 0. So it's going to be 0 to +8, and the union. And after that, a to positive infinity. All right. All right, let's check the answer. All right, it came back, and looks like we got the increasing, decreasing intervals correctly. All right, then we want to pick the correct picture. All right, so in the beginning it's increasing, and after 0 it's decreasing. All right, you can see that this does not follow the pattern because it's decreasing there. Sorry about that. And then here it's starting out decreasing, decreasing. So this is not it. This one, it's increasing, increasing, but after that, it's still increasing, so this is not it. This one, you have increasing, increasing before 0. After 0, it's decreasing, decreasing, so this is probably the correct picture. All right, so let's check the answer. All right, it came back, and looks like we got the graph correctly as well. All right, that's it. I hope that this was clear.